Hi everyone, welcome back to the same trigonometry internal video. Today I'm going to finish off task 2, which is finding all the times when Susan and Evelyn are having the most amount of fun. And this is merit and excellence, okay? So if you can correctly complete this whole part, you will be able to get excellence. So it says here, they will have the most fun when they are both going up. So when the graph is going up, they will be having fun. However, Evelyn gets nervous when she is higher than 2 meters. So for Evelyn, the graph also needs to be going up and at the same time be below than 2 meters. Because if she's higher than 2 meters, she's not going to be having fun. So because we can't compare three things at once on the graphics calculator, we need to break it down. The first thing we need to do is find when Susan is going up in that time period. So we are going to find time intervals when Susan is going upwards. Okay, so we also need to establish a time period. Now the time period is going to be lowest common multiple of Susan and Evelyn, right? Because that's when the whole pattern's going to repeat again. So we can see Susan's period is 3, right? And Evelyn's period is 4. So the lowest common multiple of 3 and 4 is equal to 12. So it repeats every 12, is it in minutes or hours? It's going to be every 12 minutes, right? So we can go, our time interval is going to only go up to 12. We're not going to go any more than 12. So pull up the graphics calculator. We are going to go into graph. Right, oh, that's an old equation, so we're just going to delete that. And we're going to put in Susan's equation, so I'm going to do that right now. Okay, so I've typed in Susan's equation, so we're going to go EXE, and there's our graph. Right, so now I've got the graph. The issue is they haven't given us a specific line that Susan needs to be over, so it's you can't just do intersect to solve. We need to know where this point is right here, where the maximum is and the minimum is. We need to find the time range there. So the way we do that is we can go G-solve, and we can go max, so F2, and EXE. Should work. Right, and as you can see, at 2.5, x equals 1. So after 1 minute, as it said in the question, after 1 minute, it will be at its maximum height. We need to find the minimum height. Right, so when it's going up, it is going to be from this point, which is 0. So we know when it's 0 to this maximum here, which if we go G-solve and max, it should give us 1. Yep, 1. So that's the first time it's going up. And then the next one is just going to be from the minimum to the maximum. So we go G-solve min 2.5. So 2.5 to the next maximum, which is going to be you go here to get to the next one, 4. And you might be able to notice a pattern soon after I keep doing this. And then same process, minimum, arrow key, yeah, 5.5. Okay, because remember we're finding all the ranges when the graph is going up. So here to here, here to here, and here to here. So 5.5, and then if we go G-solve, max, across and across, we're going to get 7. So you'll basically notice this part here goes up by 3 every time, this side. So if you can notice the pattern, that next one we can predict is going to be 8.5. And then this side's also going to go up by 3. So it's going to be 10. So that means this is going to be 11.5. Now, because the cycle repeats every 12 minutes, we're actually going to not do it to 13. We're just going to do it to 12, okay? Because after 12 minutes, it just repeats. So we're going to cut it off at 12, right? So that's all the time intervals when Susan is going upwards. Now we've got to find all the time intervals when Evelyn is going upwards and below 2 meters, remember? So we're going to do that now. So I'm going to clear these equations, exit, and we're going to delete all this. So F1 and delete. And I'm going to put in Evelyn's equation right now and the line. Right, so I've popped Evelyn's graph into the calculator with that 2 meter line. So we need to find all the regions basically from here to here, and then here to here, and then here to here, where it's going upwards and remains below this line. So we go G-solve, and now we can actually use the intersect because they've given us a sort of line. So it needs to go from, if I just do this, copy this time range, it's going to go to, it needs to be less than 1.04, so we'll round that to 1.05. And then the next range, we can ignore that. Right, it needs to be less than 5.04. So 5.05, we'll round that up. And then this here is just going to be that point there, so we need to actually use the G-solve minimum. Oh, it's actually not going to, oh, there we go, 3.66. So I'm going to put in 3.66. And then, yeah, I'm just going to do all these time ranges. You know what to do. Just basically find the point of intersection and then the minimum, and it's all these areas that are going up. Okay, now I've got all the time intervals where Evelyn is going upwards and below 2 meters. Remember, this one I cut off at 12 because that's when the period resets. So now, to find when they are both going upwards, we need to find the sections where they overlap. Okay, so now we're basically combining them together. So if I get my little time thing, the first section for Susan is 0 to 1, and the first section for Evelyn is 0 to 1.05. So for the first one, we're actually going to have to do 0 to 1, 0 to 1, because we cannot do to 1.05 because she stops going upwards at 1. Our next one, just going to copy and paste that, is going to be, if we look here, 2.5, that's outside this range, you can't use it. 3.66 sits in that range, so we can start at 3.66. And 4, does that fit in here? It does. So we can go to 4. So our next range, on to 4. Can we start at 5.5? No, we can't. Can't start at 5.5. We can start at, can't start at 7 either. So it's going to have to start at 7.66. Actually, no, it can't. It's going to have to start at 8.5, all the way at 8.5, because that's the only region of overlap, because that can fit, the 8.5 can fit in here. And it's going to go to 9.04, because it can't go to 10, because here it stops at 9.04. And then the last one should be, can't do 11.5, have to start at 11.66 to 12. And these are all the ranges when both graphs are going upwards and when Evelyn is below 2 meters. And to generalize it, so for generalizing, you add plus 12n, where n is an integer 0, 1, 2, 3, 4, dot, dot, dot. You need to have this bit here if you want to get excellence. And all you do is simply add this 12n to all these intervals. So I'm going to do that now. So plus 12n, all of them, okay? Every single one needs the plus 12n, right? And that's basically just saying the cycle will repeat every 12 minutes since ride starts. Okay. And if you can get all the way up to here, that is your excellence. You need to get everything right. So all of this needs to be correct, or else you're going to get a holistic merit. Because what happens is if you can get this correctly, but you get your merit wrong, you will be downgraded to a merit, okay? For merit, you need to find at least one time interval when Susan is going upwards, and one time interval when Evelyn is going upwards and below 2 meters. So basically, both of these two is a merit, okay? And that is it. That is this whole paper done. Pretty straightforward. It is pretty repetitive in terms of the papers. It's always going to be sort of generalizing a model, finding when it's above or below something or where it intersects. I hope that helps, and see ya.